Welcome back to the Minecraft tutorial. This is going to be part 5. In this part we're going to be covering placing blocks and also just finishing up something that we didn't have time to do in the last one for breaking the blocks. We're going to start off with the finishing of the breaking because currently right now it won't work if we try and optimize the blocks. So we need to set it up so that we can do that when we optimize the blocks. With that in mind, we're going to make 2 small changes to our chunk. And then we're going to go into our instance static mesh here and write a little function so that it handles breaking a larger block. So first in the chunk, what we want to do is we want to set ourselves up so we can test it. And so to do that, we just need to kind of replace what we already have here by a single make static mesh instance so that we have one block that actually has a scale. So we're just going to move this away for now. We will be remaking it anyway later. But for now, we just want to add one instance right here. It can be any type, it doesn't matter. We'll just leave it as grass block for now. And we simply want to call it, put it 16 by 16 in scale. So that way we can test. So just to see if this is working, the change worked, we will play. And we do indeed have our map spawning correctly. We just want to check that these are one block by checking the wireframe, and yeah, so we do have one block scaled to 16 by 16. Because currently right now, if we test it, for instance, and we break, it just gets rid of the entire area, which is not correct. So let's get into our actual blueprint to modify the block. So in ISM block again, we can remove that. We just want to modify this. This is what we put last time. It just deletes the entire instance. But here we're going to modify this quite a lot to get the results we need. So we're just going to drag our coordinates, press R on the keyboard to make a reroute, select these two, and we'll just create a function just because it will be easier with the local variables. So we'll call this modify instance, and we'll have this be coordinate broken block, we'll call this because that's what it is. And the instance index is correct, is okay for a name. So we're going to start off with a sequence. That's the first thing we need, and the sequence is simply going to be, we have this, we have our logic first for making the new block, and then we have the remove the old one. So that's as simple as it is. We want to get rid of the old one once we've fixed it or added a new one that will do the same thing, but with the extra area that needs to be removed. Next, what we need is we're going to save a few variables so that we know what we're talking about and how we can handle them later. So with our instance index, we're going to get the instance transform. And the reason we do this is that when we do because we're going to need to do a for loop, we know where we can start and where we end thanks to the transform. So we can split this and we can keep this in local space because we don't need to know the world space, doesn't matter. This we need to divide by 100. So we'll just turn it to a float because it's going to be the block start location, I guess you could say. So promote this to a local variable. We'll call L start location. There we go. We also need to take our broken block and convert it to chunk space because currently it's in world space, meaning it's block 32, 100, whatever it is. Whereas we need to have it in 16 by 16. So to solve that, we're going to get our input called broken, I believe, broken block. So what we need to do is we need to break this like that. And we need to do a modular or a modulo by the number of cubes in a chunk. And so in our case, we'll just leave that at 16. You could put a variable here to make sure that if you change it, it stays the same. And then we want to do a select float. The reason we need this is because if the broken block has a negative value, we need to convert it back to a positive location. So to do that, what we want is we will be taking this here, our modulo, and using a simple inferior value. If it's inferior to 0, that means it's negative. And in that case, we need to do a bit of math here. Very simple. We just want to have a add node that'll go in here. It'll take in the return result and the value of the amount of blocks we have, so 16. And if not, then we just simply plug in what's left. That will be the location in the chunk. Now we need to do the same thing, obviously, for the other one. So for our Y, so we just grab this and this, and if not, we can plug it in right here. There we go. Now for Z, we don't need to bother with this because height doesn't have a chunk, so we just reroute this and we can say make vector, plug these all in, line that up, and then we can just promote this to a new variable, which we will call destroy block, and we'll just assume that it's the local one because the world one is just called broken block, and this one has the L for local variable. So we can just actually collapse this so it's a bit more readable. We'll collapse this to nodes, and this will be convert world to chunk. There we go. And we can line this up. Actually, I just remember we need to make one last change here. This right now does convert the location from the broken block to world, but what we actually need to know is we need to know where it is relative to our start location as well. So to get that, we just want to subtract from here our start location, and now we have where it is relative to where it started. So now whenever we go through a loop of the start location, we'll eventually run into the destroy block and we can ignore it. That's the whole purpose of this. Next, we need to do a very basic check to see if this block is actually 1 by 1, because if it's 1 by 1, we can just remove the instance alone. We don't need to do this. So we're actually going to save our scale here as well. We're going to reroute this, and we're going to say if it is double equal to 0, and we'll just add a little bit here to make sure that it actually gets it. And we don't want to say, sorry, not 0, 1. And that means that, well, we're actually breaking a 1 by 1 by 1 block, so it doesn't matter. We can just ignore all the rest and just simply remove the instance, just like we did in our original test last video. Now with this in mind, we now want to save this because we need it later as well. So we're going to reroute, and this time we don't need to scale or anything because it's the scale, so it's only 1 by 1 values anyway. So we will save this as scale. So promote that. And we'll just move this down. There we go. And now we can get into the spaghetti part. Now we're actually going to do a for loop on all 3 of these scales. So we're going to do for loop here. We're going to start at 0, and we're going to finish at our scale. Let's break it on Z. So we'll want to actually just floor this. Normally that should always be fine. There we go. If not, we'll have to round it, but it should be okay. There you go. So this will be our first one. Then we're going to do the same thing. Yeah, we're going to do the same thing, but with our Y after this. And there's some stuff to add between, so don't go and connect them yet. We're just going to place them all first. And the last one will be X, obviously. So the first thing we need to do is now we're going to add a few little variables that allow us to keep track of how the item is changing over time. So the first thing we're going to need is we're going to need another vector again, and this is going to be our current location. So this is as we go through the loop, we'll check the current location to see how it is relative to the destroyed block, the start, the scale. So with our current location here, we want to break it, and we want to get the Z. And we're going to say Z minus the start location Z, so we can just copy this to be fair, and just replace our scale by right-clicking with start location. And we want to subtract it. And if any point this is superior or equal to a new variable we're going to make, which is right here, we will promote to local. This will be Z scale. This is going to be used to track how big the scale is going to be for each new instance we are adding in this kind of loop. And if this is true, so we'll just actually move this, we need a bit more space than I thought, we get to increment it. So pretty much this is just a check as we go through if the conditions are met that this can actually get bigger, because by default we don't want it to do that unless we have a uniform kind of scale, because we don't want the item to be, the item has to be a square at the end of the day, so we can't increment it in certain conditions. Now, so here we want to then say control and place. We want to say ++ for increment, and we can then ignore it if it is false, because we still want to do the rest of the logic. So a reroute here just to make it more readable, and we'll just connect this up for the Y next, and we're going to do pretty much the exact same thing after as well for the Y. So for the Y, we'll just copy this. We'll just make a new variable in a second. Just place it here. Actually, to be fair, let's just get the whole thing. There we go. We'll just move our X out of the way for now. Place it, plug it in, and now we just need to change this to Y, change this to Y. And we can promote this to a new variable, local L, and this is Y_scale. There we go. So now we can just right click to change it. And obviously the same needs to be done here as well. There we go. So this is the same thing as for the Z, we just do it now for the Y, and we'll need to do it one last time for the X as well. But the first thing we can also do right here is we'll just plug the X in, and we will paste again for our new thing, for the third one. And this time we use X instead of Z, line this up, and promote this to another variable, which we'll call LX_scale. There we go. Right click, make sure they're all set to the right value, so X here, and we have Y before it, Y here, make sure you're using the same here, then Z with the same values here. Now, once we've done this for the X, we actually need to save our current location, because we don't have that yet. So we're going to place it here, and we're going to go all the way to the beginning here, and this is our Z value. So we're just going to drag it all the way here. I'm pressing R, by the way, while holding it to add the reroute, and then we're going to do the same thing for the Y. So have this above. There you go, right here, and the last one, which is the X, which will go right here as well. And for some reason that changed the direction. There we go. Okay. So now with these, we just need to convert them to make a vector. So we'll just say make vector, and it will just convert them back to floats here. And to be fair, this isn't actually necessary because we have these, but whatever, it's fine for now, won't matter. So now we need to get into the more spaghetti stuff, if you can believe we weren't even there yet. We'll start off with the sequence, and the first thing of the sequence is we need to have a check. We need to check whether we are attempting to make a new instance, because at all times that may not be the case. So for that check, we need a branch. We need a boolean here that we're going to make, which we'll be calling a new start. There we go. Now, the new start by default has to be true. So make sure you have this checked, otherwise the whole system doesn't actually start because it is never true. So when this does happen though, we want this to become false, because now it's happened once. We only want to call it once we want to create a new instance. So next, we need to actually store a new start location, and this is for where the new block will be. So we're going to duplicate our current location. We'll call it L new start block. There we go. This will go in here, and it will take in the current location like this. And finally, just to make sure, we will be placing all of these right here and setting them once we start a new value. Now, Z and Y need to be set to 1, but X needs to be left at 0. So make sure you have it like this. We have X, Y, and Z. Z is at 0, Y is 1, Z is 1. And that does it for this branch. Now the next thing is we need to check the conditions for where do we need to stop? Where does the problem occur? So the problem occurs when we have our destroy block. And so our destroy block, very simply, is our destroy block double equal to our current location? If it is, then we need to stop. That means that we've hit the problem and we need to remove it. Sorry, so I'm actually going to make one small change because here it might not be very clear. We're just going to rename this our start location, the initial one. So that's the one all the way back here. We're going to rename it to block location. That way it's clear that we're not talking about this start, just to be sure. So let's go back to over here. So on success, what we need to do is we need to also check that the start location, so right here, is different from our actual destroy block. Because if it is, we would have this happen because destroy location would be called as it would be the same location. But if it is the same as the start, then we don't actually want to spawn a new item because we know that that's not possible because this is supposed to be destroyed. So in that case, we need to ignore what's happening here. So we'll reroute this. And now here, what we need to do is we're going to need to add a new function that's going to store the transforms we're going to create. So it's not a function, it's actually just an array, but we need some stuff to be added. So we're going to call this new transforms. There we go. Right click on the boolean here to turn it into an array, and we will swap it to a type of transform. Then here we're going to say add, like this. And here is where it gets a bit more complicated. We're going to put a reroute node, and we're going to collapse this to collapse the nodes because we're going to need a bit of space, I believe. So call this make transform. That's exactly what we're going to do inside of it. So control click to open it on a different tab. And to be fair, it's more like it takes a bit of space, but we could also leave this uncollapsed, it doesn't really matter. We want to make transform here. And what we need is very simple. We want to get our start location. We want to add that to our block location because we need to, for our instances, it's relative to the whole chunk and not just this block. So we need to make sure that we set that to be the case. And we then need to multiply this by 100 because once again, this is a block. It is not actually the world space. So to float 100, plug it into location. Line these up. And now simply for the scale, we can actually just plug in these three as a vector. So make vector here, plug the three of them in. Actually, that's the wrong way around. X should be there. So make sure these are actually set up correctly and plug that into the scale. And that will do it for our make transform. So we can just double click out of here to go back. There we go. So that will do it for our transforms. And obviously now that we have placed a new item, we need to start again. So we're going to get our start here and set it to true. Now, if we don't want to place something, we still want to restart because we might need a new item. Or we might need a new instance, sorry. Now, one other thing we do before this, we actually need to add another check right here that on true will perform the same thing. Actually, it won't do that. It will ignore that. It will just immediately go to true here. So I'm just going to add a little reroutes, even though it might be a bit messy. There we go. So what we want to check here is we're going to get our current location. We're going to break it. We're going to get our start location. So right here, we're going to break that. And we're going to check the values here. We want to check whether this, so the x of the current is inferior to the x of the start. And we'll do the same thing for the y. So if either of these are true, so we'll put or. And currently, the z here is superior. So the current location that we're at is higher than the new one. So the whole point of this check right here, just to explain it in an example, will probably make it easier. The point of this is if you have a block, let's say that is 2 in height and 3 in length and 3 in width. If you were to break the bottom block, row 0, you break the block in coordinates 1, 1. So if you do that, you need to be sure that when you start building a new block, that when you go up back to 0, 0, that it's considered invalid, because that would no longer be a cube, or that would no longer be a square, because you would have to be going in diagonal. So if ever that happens, meaning that x here or y here is inferior to where we started, then we want to stop. That means it's not possible, we can't keep going, so we need to reset, let's say. And so that's what this will check for, because this won't suffice to check for that. So right here, we now need to actually do one last thing, is currently, if we were to break a block and place a block, these extra blocks, we kind of end up with an issue. Because if we place a block and realize there's an issue, we are still already at that coordinate, but we can't place the block there, so we need to go back to those coordinates to retry and place a new one. Otherwise we'd end up with extra holes we don't want. So that's what we need to do here, where we're going to check what conditions we met. So which block or which line should we restart? Should we restart the X? Should we restart the Y? And so based on that, we'll be able to fill in the gaps. The first condition we want to check, so we'll put a branch here, is we want to get our start location. So let me just pull that up here. We want to get our destroy location. We want to break these, like this, for both of them, so just copy it. There we go. And we want to check whether the Y is double equal between them and the row is double equal between them, or the height, so Z. And so if both of these are true, that means that the block we are trying to break doesn't need to be reset. And the reason for this is very simple. If we break the block on the same as the start, then it doesn't matter. We can just ignore the rest because we would just start on the next block and keep going. Now, on the other hand, so here we do nothing, but on false, we do need to do something. So on false, we need to do one last check, which is we are going to get our start location again. So we'll get both of these, I believe. Yeah, both of these. And if the row is different from the Y, but these two are double equal, meaning we're on the same level still. So and, like this, there we go. Plug these in. If this happens, then that means on true, we want to reset the X. We want to redo the entire X. Now, the reason for that is because, well, we just did a start that went all the way to the end of this X axis, and we started on the next one, so the Y, the Y1, for instance, and we found an issue. Now, if we found an issue there, we need to redo that entire second row, so that entire Y axis 1. And the reason is because, well, it would be, for instance, x15 on 1 or on 0, and then it would be x, for instance, 5, which wouldn't work. It wouldn't be a cube anymore. So we would have to remove that. So say that x is only limited to 1 times 15. And then we would have to do the second row again and say, oh, well, we started here. We found an issue, so now we can just continue, because then we would end up on this condition again. So here, we want to reroute all the way back, so drag this all the way back to the X. So make sure this is the X, we just place it here. And we can just add some reroutes, because otherwise this will be very hard to understand what it's doing. So right all the way back here. There we go. So if this helps, we'll just add a quick thing here. So this is where we are attempting to make a 2D box along the same level. And so if it's true, that means that we are not on the same Y. So that means that we didn't start at the right location. Now, on the other hand, if this is false, what it means, given that we went through here and we know that these two aren't, that one of these is false, if this isn't true, then that means, if this one is true, then that means it would have been true here. And so that means this here automatically has to be false. So that means that we have to restart the Y as well. So this time we want to reroute all the way back to the beginning as well, but this time for the Y. Now, let's just grab another reroute here. And we'll just double click again, just to bring it around. Put that bit higher. There we go. So now we're not done yet. We still have 2 or 3 little things left to do, and that is we need to actually create these instances. So the place where we want to actually create them is once the X is complete, we have to do one thing. So we're going to put a branch here after the X, so make sure you're on the X one here. Actually, I just realized, but I made a little mistake here. This should be -1. I just realized because we start at 0, so the scale should be -1, and that's the case for all of these. So for the L, for the scale Y as well. So this for all the for loops, just need to go back through them and put a -1 again. There we go. There we go. Like this. There we go. Now, so back after X, what we want to check is we want to see if our start location right here, if the X is different from 0, then we want to actually do something here. We want to do a do once, because we only want this to happen once. It only should happen once. And what we want to do is we want to kind of do the same thing as here. So we're going to copy these 3 nodes here, 2/3 nodes, copy them and paste them right here. And so right here, we can double click on this because I believe it needs to be slightly different. Yeah, so for this one, we need to make a slight change for the X. We want to actually remove this or move it away. We want to do +1. And we want to put this in a clamp, sorry. So right here, and this goes into that. Now, for the minimum, it is 1, because the scale should always be 1 minimum. But for the max, we'll just put in, we will get our block scale here. We will split it just to get the X, and we'll say minus the start location. So this one right here. Right click, so new start block, sorry. And we'll place that in max. There we go. So that'll do it for this part. Then we need to go back again to our modified instance. And this is make transform to, you can leave it, it's just fine as a name. Or if you want to make it clear, you can also uncollapse it just so that we can actually see, so expand. When this is called, just so you understand, this is called when we reset the X, because if we reset the X, we need to let it know that we need to place an item. This should only happen once, and the reason we have it do once is because there is only one hole we break at a time, because we only input one block that broke. So that means we only break it once. So it can only happen once. Now we need to move now to the end of all of the for loops, so right here, so for the Z, and we'll have another branch right here. So what we need to check is if the last coordinate, so our current location, is different from our block to destroy. Because if here normally we reach the end, we would need to say, oh well, we're at the end, we need to spawn one last instance in case, because well, the logic itself doesn't do that for the end. So we need to say if we reach the end, we need to spawn one. But if the end is the block we're trying to break, we don't want to do that. So right here, if it is the end block, we don't do it. So if it is different, and we also want to check that this is not true, we can say condition met, and then we can actually make another transform. So I don't know if we start the paste. So yeah, we want to paste the same thing again because it's pretty much the same structure. We don't need the new start though this time. And we want to open it. I'm just going to double check that we have. Okay, so here we have a bit more to do. So here we need to actually break pretty much the entire thing. And we're going to actually not break it. We want to copy them, keep them here. And we're going to need a bit of space because we have a few things to add here. We're going to do +1 for all of them. +1. There we go. So just copy this because it's going to be used for all 3 of them. And there we go. So now what we want to do is we want to also use the clamp float like before. Like this. Then we want to get our block scale. So our scale here. We want to split it to get the X, which will be subtracting once again from the start location. So split this one as well, X as well. And we'll be doing pretty much the same thing for all 3 of them here. So once again, minimum of 1, scale will always be a minimum of 1. I think we'll just actually remove this. We will copy them because they should be the exact same either way. There we go. So make sure for the second one, right click, scale Y, replace these with the Y, align them up, plug it in, and this one needs to be Z. There we go. And the same thing obviously for the variables there. Plug this into the Z as well, compile, save, and that should do it for our third one. And now we can finally finish this off by saying, well, if this isn't empty, so if our transform is not empty, this go. So we do need to reroute here, because if the conditions aren't met to place the extra one, we don't want to, we'll just ignore it. If our transform is not empty, in most cases it shouldn't be, we want to say add instances, plural this time, and we will just plug in the actual transform that we're trying to place. So just drag that into the instance transforms, and there we go. So this should do it for the breaking of one block in a actually scaled system. So let's have a look. Let's play. If we go and look now at the actual block itself and see it in wireframe, we do still have a one big block. Now let's see if we go and try and break it. It doesn't seem to be breaking. I think the issue lies with the cube here, where it's not actually in the right position. It's above. So I think what we need to do to fix that is in our first person character, if we get our origin here, I believe. I think if we multiply this by like a value, I think a 5 should do the trick. I think it's just because it's so large that it doesn't actually shift it enough inwards. There we go. So now if we break it, we get our actual block that's broken here. We have one block broken, and then we have the rest that actually gets set up correctly. So we have one here, it fills the rest, and then this whole thing is one big block. So that's how it should be working. You can look at the wireframe to see if this functioned correctly. And if we look correctly, we don't have any. Also, the reason I moved that just to check is because sometimes you can have duplicates. And to check for duplicates, you'll usually see that it flickers. And I'll give you a good example if it's duplicated. So just to check that it wasn't, it was actually the cube that was giving that kind of flickering effect. So this is now working. And let's try and break another one just to be sure. So we do have a little issue. So right here, as you can see, we broke more than we wanted. That's not what's supposed to happen. We were supposed to have this appear and then that disappear. So I'm just going to double check that again. I think what was happening is it doesn't like that we break the second row. So if we do it here, it has the same effect. But if we break it here, it's worse. Okay, so one of the mistakes I made right here in the modify instance, obviously, for the scale Z and for the scale Y and the scale X, I accidentally here put the block. So it was like this, but what we actually need is we need to use the start block location. So the local one within this loop needs to be used here, not the block location itself. So I went ahead and changed these. So new start and new start right here. And if we play it again now, it still has a bit of a bug. But now if we go and break, for instance, this one, it doesn't have the issue of erasing extra stuff that shouldn't. So I'm going to get back to you once I fix this last little bit here. Okay, I figured out where the issue is. For some reason, when I said connect these resets all the way to their for loops, I didn't do that. So the bottom one should be going to X right here, and the top one should be going to Y. And for some reason, I just didn't do that. So please plug them in correctly. Don't be an idiot like me, otherwise it won't work. Obviously, if I don't do what I said, it's not going to fucking work. So now, normally, if you go ahead and break, there we go. We are in the middle of the box, and it does break correctly. So let's try again in this one, just to be sure. And we'll try again here to be sure as well. And it's breaking correctly. Let's go. So if we break after, fine as well. If we break before, no problem as well. And I think one extra one we want to test is we will try and break the corner block, the last one, just to be sure that everything is fine. So if we break the last one, Yep, works just fine as well. So there we have it for the breaking blocks. It is done. And now on to the next part, which should be the main part of this video, but it's going to take 5 minutes compared to the 40 minutes we just spent on that. So let's get into it. So the next thing we want to do is we want to work on placing a block. So for placing a block, first we need to add our interaction system. So we need to add, instead of mind block, we want to add place block. So for placing block, we want to do the same thing, but we want to add one condition. So actually we're going to duplicate this, and instead of mind block, it's going to be place block. And so the last thing we need to have for the inputs is we need to know which direction we want to place it in. So for that, we need a normal vector, or just a vector. So this is going to be the normal. And so we can compile and save. And inside of ISM block, we can go to event graph and add that place block. So what we want to do here is, before we can actually place the item, we need to know where we are placing it. So what we're going to do to make things easy is we're going to say, well, we're going to place it in a parent chunk, and that chunk is going to be, well, the location where it's placed. So for that, we're going to make a new variable, which we will call parent chunk, and it's going to be of type, well, a chunk, like this. Right click just to turn it back to a normal variable. We're going to get that, and we're going to say make instance static mesh, because that's what we're placing in this case. And normally, if you want to add something for which type of block we're going to place, which we should probably do, to be fair, we will add to our place block the block we actually want to place. And so this is going to be a DA base, and it's going to be a soft reference as usual. Compile and save. So we don't need the BPI anymore, but now we get to say here, this is the input we want to make, and we're going to say add instance. And because we already have this function set up, it will handle the rest. We just need to then say coordinates plus the normal. Yeah. So we'll need to actually convert this. So what we'll do is, in our modify instance right here, we have this, and we'll actually collapse it to a function, which we'll call world to chunk, and we'll make this pure. There we go. Now by default it will still have this, so we can just give it a bit of extra space and expand. With this new function right here, we can actually convert this from world to chunk, and we can add the normal. Now by default the normal is just a normalized vector anyway, so it'll always be 1. So then we just multiply this by 100 to scale it back to physical positions, like this. Actually, I just realized we need to also divide this by 100 first. So let's just do that. And now we can actually convert it properly. Now, hopefully this does the trick. It should do the trick normally. So this will do what we need it to do. We just need to actually go back into here and actually inform this that we actually saved the information here. So we need to connect the parent chunk. So to do that, we want to do instance editable here, expose on spawn, so that this variable actually appears in this function, so we can just easily set it up. So right here in our a chunk, in our function make instance static mesh, we can very easily now just connect self here just to inform it what its parent is. So we need to do the same thing in our foliage, even though normally we can't place on foliage itself. We'll just do it for safety. There we go. So now we just need to go to the player, so inside of the player character, and we just need to perform our right click here. So it's actually pretty simple. We just want to take our started. We will check if get hovering block is true. We'll convert it to started, and if it is, we can say place block. Make sure you use the message, and the target will be obviously hovering block. The block for us will be grass, because that's all we have. And then we just need to place our coordinates. So hovered 1. For the hit item, we just put hit item. And for the normal, I don't know if we made it. Yeah, we do. We have get impact normal. So this will be used as well. And so to finish up, let's just go ahead and test. So if we go and right click, oh, well, we do have a block. It is not spawning in the right location at all. But it is spawning a block, so that's good enough. Let's try and figure out why it's not going to the right spots. Oh, I think this is why. I think it's because we've already converted it to coordinates and I'm stupid and didn't need that. So inside of our ISM block, we don't need the divided by 100. Let's try and place, and we can place on top of them, place to the sides. Let's just try and place strictly on the edge. Still fine as well. So this works just fine. Just like in Minecraft, we can make anything we want now. So it would be nice with some more materials or more blocks, but for now this is fine. It works just as intended. We can place blocks wherever we want. We can actually climb up as well with it. So I hope you enjoyed this part. In the next part we're actually going to be finally covering some generation, as in more than just simply the height map. So I look forward to doing that part. I hope you enjoyed, and I will see you in the next part. Goodbye.